Guys, welcome to another lecture from Introductory Statistics. Now we are moving towards the concept of probability distributions. Before understanding probability distribution, there's one very important concept that we all need to understand, and that's the concept of random variables. As the name suggests, variable, right? Now, why do we have this word random attached to it? Random variable is a variable which can take values randomly without any bias. But what exactly is this? In probability, when we take up any experiment, let's say experiment of tossing two coins. Now, if I toss two coins, I can get head or tail with the first coin, and I can get head tail with the next coin. So that means my sample space is head head, head tail, tail head, tail tail. These are the four outcomes that can actually come. Now, I might not be interested in this sample space per se, but I might be interested in one characteristic of this experiment, of this sample space. And say, for example, that characteristic is that I'm interested in the number of heads. How many heads am I getting? So can you see how many heads you are getting? Well, if I take up this case, I'm getting two heads. In this case, I'm getting one head. In this case, I'm getting one head. And in this case, I'm getting 0 heads, right? So this number of heads is your random variable X, because this can take different values randomly according to the outcomes in the sample space. So what is this random variable? A random variable is a real valued function that associates each outcome of the experiment to a real number. That is, what you can see here is your sample space S in this example is head head, head tail, tail head, tail tail. Now each outcome is associated to a number, right? So this is the domain of the random variable. X is the random variable with the domain as your sample space. And it is taking this sample space to a range which consists of real numbers. In this case, it consists 0, 1, 2. Since we are tossing two coins or tossing one coin twice, you can say, therefore, at the maximum, I can get two heads. And at the minimum, there can be a case of tail, and therefore, there can be no heads at all. This is what is the concept of random variable. Why is it so important to understand random variable? नाम वेरिएबल है, पर काम क्या है? काम है फंक्शन का. Always remember, a random variable is nothing but a function. Because mathematically speaking, what is it doing? It is giving a unique image. Every outcome in your experiment, according to the variable that you are taking, will take up a unique number or a unique image. That is why a random variable is a function or a mapping. So formally speaking, what is a random variable? For a given sample space S of some experiment, a random variable is any rule that associates a number with each outcome in S. Now, when I said unique number, please try to understand, just like in functions, this is your sample space and this is the range. Let us take the example that we had taken. So here I have HH, HT, TH, and TT. And the random variable that we have taken up is the number of heads. As you can see, this outcome is associated to 2. This outcome is associated to 1. This outcome is associated to 1. And this outcome is associated to 0. Yes, it's a many-to-one function. So when I said unique image, please understand exactly the way we have understood in functions. Unique image means you can have a many-to-one relation here, okay? This is what is something that you should keep in your mind when you are thinking about random variable. Now, with the same experiment, you can generate different random variables. For example, with the same experiment, the sample space will not change. The sample space will be head, 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 tail, tail, head, tail, tail. And this time we can take the random variable as number of tails. It's going to be almost the same thing. The only difference will be the value these outcomes are taking. Head, head will give you 0 tails. Head, tail, 1, tail, head, 1 tail, tail, tail this time gives you the outcome 2. Okay, so this is how you can keep the sense of random variables in your mind. Okay, now suppose this random variable is called x and this random variable is called y. Always remember, how do we denote random variables? We use capital letters. So capital X, capital Y. Okay. Now we can even generate some more random variables. With this example itself, what if I want to generate a random variable X minus Y? Absolutely, you can do that. What does it mean? This means I'm talking about number of heads minus number of tails. Now, in the case of the outcome head, head, your number of heads is 2, but number of tails is 0. So hence the value that this will generate is 2. In the case of head, tail, the number of heads is 1 and the number of tails is also 1. So 1 minus 1, the value that it generates is 0. Tail, head, again 1 head, 1 tail. So 1 minus 1 gives you 0. Tail, tail. Now this time you have 0 heads, but you have 2 tails, so minus 2. And hence 0 minus 2 gives you minus 2. So this means this time what we have, again your domain is S, the sample space, and it is taking the random variable. This mapping is 2 minus 2, 0, 2. That's the range. Okay, so function is x minus y and the domain is S and the range is minus 2, 0, 2. This is how you can generate a lot of random variables from just one experiment itself. That's why I've given you this example. Like this, now you should think about some more examples and try to clarify to yourself. Try to think in any probability example, in any probability experiment, you should try and generate random variables. Random variable is a mapping that will take the sample space to certain real numbers, each outcome in the sample space. The random variable will be taking it to a real value. Thank you very much. I hope this is clear to you guys because this is the base for the next thing that we will be working upon, and that's probability distributions. Thank you very much.